Assalamu alaikum, my dear student. Today our topic is simple harmonic motions. Simple harmonic motions. The discovery first published in 1822 by the French mathematician Joseph Fourier. Joseph Joseph Fourier. And how it defines simple harmonic motions and how it defines a particle is said to execute simple harmonic motion if its acceleration is directed toward the main position. Means, for example, this is a figures we proves the accelerations of this block is directly proportional to main position or display or mean positions. Mean position means the rest positions of spring is equilibrium positions. If we increasing block from this side after increasing the back toward means moves back with the force of restoring force and accelerations is directed toward the equilibrium positions and its magnitude is directly proportional to displacement from the main positions. Mean acceleration is directed toward the equilibrium position. Mean acceleration is directed toward the main positions. Mean if we increases or stress they after stressing and after enhancing they back toward the equilibrium positions, and same is its magnitude is directly proportional to displacement from the main position and its magnitude is directly proportional to from the equilibrium positions. Okay, understands. For examples, a linear simple harmonic motions. Let F be the restoring force on the oscillator of block. F be a restoring force when its displacement from the equilibrium position means F is directly proportional to X. And what is negative sign? Negative signs mean restoring force. Negative sign mean restoring force. What is restoring force? Restoring force is a function only of positions of the mass or particles. It is always directed back toward the equilibrium positions of the systems. Okay, understands? Means directed back toward the equilibrium position is called restoring force. And what is K? K is a proportionality constant is called force constant is called force constant. Okay, clear? And now we find the equations of simple harmonic motions. And first, F is equal to m, Newton's second law. What is m? M A is equal to minus k and A is equal to d squares x and dt over dt square. This is accelerations. We use value here and then put here. Okay, understand? And then after back side page we proves this, but this is negative signs. We convert this value from left hand side, then also sign convert minus, then convert into plus, then m. This is equation 2. Divide both side by m, then is equal to divide both side m. Clear? Understand? This m is cancel is equal to this. Okay, let we always the value here is angular velocity. Angular velocity omega is equal to square root k over m, square root k over m, but here without square root, then taking square both side is equal to omega square, and this is equal to k over m. We know that the square root value is 1 over 2, then we take square, then is equal to 1 and put his value here. Okay, and now we find time period. What is time period? Time period, we know that T is equal to 2 pi angular frequency. We also called here angular frequency. Called angular frequency. Okay. Omega is equal to, we know that omega this, but we convert this is equal to 2 pi m over k, and also frequency is equal to 1 over t and is equal to this. Clear? Understand?